Ask a chatbot to write you a poem. It'll do it, and honestly, it'll be pretty good. Now ask it how many letters are in the word strawberry. It might get that wrong. That's odd, isn't it? It can write poetry. It can't always count to 10. Hang on to that. We'll come back to it in about 20 minutes, and by then, you'll know exactly why. Right. So what is deep learning? Here's the answer you'll find pretty much everywhere. Deep learning is a way of getting a computer to work something out from examples, instead of being told the rules. That's correct, it's also completely useless. And I think you can feel that it's useless. So we'll do it backwards. I'll build one with you. At the end, I'll say that sentence again, and it'll actually mean something. One thing first. Everything I draw here, you can go and play with. There's a free page linked below where you drag the dials yourself and break it on purpose. That's the fastest way to learn this. Use it. 2 quick bits of housekeeping, then we build. You'll hear 3 words thrown about like they mean the same thing. They don't. They're nested, like boxes inside boxes. Artificial intelligence is the big box. That's anything where a machine does something that looks clever. Inside it sits machine learning. That's when the machine works something out from examples, instead of a person writing the rules down. And inside that sits deep learning. Same idea, built in layers. And that's where the word deep comes from. It isn't deep as in profound, it's deep as in stacked up. That's the whole reason for the name. Slightly disappointing, I know. 3 quick things it isn't, because these trip up everybody. It isn't a computer becoming conscious. Nothing in this video is anywhere near that. It isn't magic. By minute 20, you'll be a bit disappointed by how simple it actually is. And it isn't looking answers up in a big table. There is no table. That one matters, and it explains a lot of the odd behavior later. Housekeeping done. Let's go. Before we build anything, I want to show you something. You've already used deep learning today, probably before you finished your coffee. You unlocked your phone with your face. That's this. A junk email got binned before you ever saw it. That's this. Your phone quietly fixed a word you'd typed badly. This. Something put a row of videos in front of you that it reckoned you'd click. This. Somebody sent you a voice note and your phone wrote out what they said. This. And if you asked a chatbot anything at all, well, that's the big one. That's 6. And it isn't 9 o'clock yet. Now here's the bit I find genuinely strange. It's also why this video is 30 minutes long and not 30 hours. Every single one of those is the same trick. Not similar tricks, the same one. Face unlock, the spam filter, and the chatbot are the same idea at different sizes. That's it. So we only have to learn one thing properly. Let's go and learn it.
Right, we're going to build a brain. A very stupid brain, but a real one. And here's my promise before we start. No maths. None. If you can split a restaurant bill, you're overqualified for this. So, we want to guess whether you'll like a film. Here's the thing though, you already do this. You do it every time you scroll past something. You glance at a few things. Is it funny? Is it 3 hours long? Does stuff blow up? And some of those matter more to you than others. If you hate long films, 3 hours is a deal breaker all on its own. If you love explosions, that one counts double. That's it. That's the whole idea. You weigh up a few clues, and some clues count more than others. Congratulations, you just understood a neural network. Let me spend 2 minutes proving it. 3 clues going in. Funny, long, explosions. Each clue gets a dial. The dial is just how much this one counts. Turn it up, that clue matters more. Turn it down, it matters less. That's all a dial is. Now we add it all up. Funny times its dial, length times its dial, explosions times its dial. Add the 3 together. One number pops out. That's the guess. It reckons 4 out of 10. The real answer was 8, so it's wrong. Wrong by 4. It's wrong because the dials started at random. Nobody set them. Now watch this, because this is the only genuinely clever bit in the entire video. The machine can work out which dial made the biggest mess. Not guess, work it out, properly. And then it nudges that dial, a tiny bit, in the better direction. Guess again, 4.3. Still wrong, but less wrong. Do it again. Different film. Again. And again. A few billion times. And that's deep learning. 4 words. Guess, check, nudge, repeat. Guess. Check how wrong you were. Nudge the dials. Do it again. Those numbers on your screen are real, by the way. That's an actual machine learning, right now, while you watch. Nobody set those dials. The only thing moving them is the mistake getting smaller. And remember that junk email? This is that. The clues are words in the email. The dials decide which words look dodgy. It guessed, got told it was wrong a few million times, and nudged. One problem, though. Our little brain can only do one shape, a straight line. That's all it's got. And almost nothing in real life is a straight line. So, a straight line. Let me show you why that's a problem, with dots. Here's a page, red dots and blue dots. Your job is to separate them, and you get one straight line to do it with. Sometimes that's easy. Red's over here, blue's over there. Line down the middle, done. And congratulations, you've just done exactly what our machine does. Now here's a different page. The blue dots are in a little cluster in the middle. The red dots are in a ring all the way around them. Go on, try it. One straight line. You can't. And it's not that you're not clever enough. There is no angle that works. That line does not exist. Our machine has this exact problem. Multiply things by dials, add them up, and a straight line is the only shape you can ever get. So we fix it. And the fix is one word: bend. After it adds everything up, we bend the answer. That's the whole fix. Now this bend has a proper name, and the name is horrible. It's called an activation function. Someone picked that name and they were not thinking about you. Forget it, it's a bend. One bend gets you a curve. Better, still not a ring, so we stack them. Add, then bend. Add, then bend. Add, then bend. Every bend lets the line curl a little further. Stack enough of them and you can wrap that ring completely. And on the way, something happens that I think is genuinely lovely. Say we feed it photographs instead of dots. The first layer learns to spot tiny lines, little edges. Nobody told it to look for edges. It just worked out that edges are useful. The second layer takes those edges and builds corners and curves. The third takes those and builds eyes, wheels, letters. Keep stacking and you get whole faces, which, by the way, is how your phone knows it's you. Nobody designed that. Nobody sat down and said, right, layer 1 does edges. Each layer just found something useful in whatever the layer underneath it found. And those stacked layers are where the name comes from. Deep learning is deep because the layers are stacked up. Slightly disappointing, isn't it? Now, one thing you'll hear constantly, and it's worth getting right. You'll see a headline about a model with 400 billion parameters. A parameter is a dial. So that number tells you how many dials the thing has. Nothing else. It's like being told a box is enormous. It might have something wonderful inside. It might have almost nothing. The size tells you about the box. So, where are we? We've got a machine that can draw almost any shape, and it has billions of dials. And we have absolutely no idea what to set them to. Remember how we fixed the dials last time? Work out which one made the mess, nudge it, try again. That was 3 dials. Now do that 400 billion times. So who turns them? Nobody. Nobody turns them. That's the answer. And this is the bit people find hardest, so I'm going to go slowly. Here's what happens instead. It rolls downhill. Right. Picture a field in the dark. Properly dark, you can't see a thing. And somewhere in this field, there's a dip, the lowest point. You want to get to it. You can't see it, but you can feel the ground under your feet. So you feel which way slopes down. You take a step that way. Then you feel again, and you step again. And you'll get there, in the dark, without ever seeing where you're going. That's it.
That's how a machine with billions of dials gets trained. This has a name. It's called gradient descent. Gradient means slope. Descent means going down. So the name means walking downhill, which is a lot of syllables for walking downhill. But hang on, downhill on what? Here's the clever bit. We turn "how wrong am I" into a place. Every setting of the dials gives you some amount of wrong. Set them one way, you're badly wrong. Nudge them, you're a bit less wrong. All those settings together make a landscape. Hills where the machine is terrible. Valleys where it's good. And training is just walking down that landscape until you find a valley. Now, one thing decides whether this works at all: how big a step you take. Take tiny steps and you'll get there, eventually, sometime next year. Take enormous steps and something worse happens. You overshoot the bottom. You land on the other side. You overshoot back. And you fly further out every single time. Same field, same starting point. The only difference is the size of the step. Get that wrong and it never finds anything. That step size has a name too: learning rate. And picking it is more of an art than anybody would like. Now, why does this cost millions? Billions of dials. Every step, work out the slope for every single one. Then take millions of steps. Then run all of that on thousands of specialized chips for weeks. That's the bill. And here's the thing to take away, because it explains a lot later. At no point in any of this does the machine understand anything. It isn't thinking about films. It isn't thinking. It's a ball rolling down a hill, and the hill is made of how wrong it is. Everything that looks like understanding later is a side effect of that ball finding a very good valley, which means something you can use today. If you type "be more accurate" into a chatbot, you're asking for something it was never rolling towards. Nothing in it was ever pointed at true. It was pointed at less wrong on the examples it saw. So ask for sources instead. Ask it to show it's working. Narrow the question down. Those you can actually check. Right. Our machine trains itself now. It rolls downhill until it's barely wrong at all. So we're finished. Except we're not. Because there is a way to get that number down to almost nothing and still be completely useless. And our machine is about to find it.
It cheats. That's what it does, and it's very good at it. Here's what I mean, and you already know this one. Think about someone revising for an exam. There are two ways to do it. You can understand the subject, or you can memorize last year's paper. Memorizing is faster, and if this year's paper happens to be last year's paper, you'll get full marks. You just won't be able to answer a single question you haven't seen before. That is exactly what our machine does, if you let it. Remember, all it wants is for that number to go down. Nobody ever told it to understand films. So the laziest way to get the number down is to memorize the answers. Give it 1,000 films with 1,000 scores. Give it enough dials, and it will simply remember all 1,000. Error almost zero. Looks perfect. Show it film number 1001, and it hasn't got a clue. This has a name, and for once the name is fair. It's called overfitting. It fitted the examples too well. So how do you catch it? The same way a teacher does. You don't let it see the test. Take your 1,000 films, hide 200 of them in a drawer, train on the other 800,
Then, right at the end, bring out the 200 it has never seen and mark it on those. Does well on the 800, badly on the 200? It memorized. Does well on both? It actually learned something. That's the whole trick. And it is the single most useful idea in this video for spotting nonsense. But there's a nastier version, and this one is much harder to catch. Sometimes it doesn't memorize the answers, it finds a shortcut. Say you want it to spot sheep in photographs, so you collect a few thousand photos of sheep, and because sheep live in fields, every single one of your sheep photos has grass in it. Your machine gets very good. Everyone's delighted, it has learned grass. Show it a sheep on a beach and it sees nothing. Show it an empty field and it says sheep. And it was never wrong, exactly. It got the right answer, over and over, for completely the wrong reason. So, something you can use today. When a prompt works beautifully on the example you tested it on and then falls apart on real work, that is this. You tested it on the thing it had already seen. And when a model scores brilliantly on some benchmark, that benchmark is somebody's exam paper. It tells you how it does on that paper. It doesn't tell you how it does on yours. So try it on your own awkward cases, the ones where you already know the answer. That's your 200 in the drawer. Right, we can train it now, and we can catch it cheating. Which means we're finally ready to build the thing you actually came here for. The one that finishes your sentences. Except there's a problem. Everything we've built runs on numbers. Every dial, every slope, every guess. Numbers. And a word is not a number. A word is not a number. So we're stuck, unless we can turn one into the other. And the obvious way to do that is wrong. Let me show you why. Because the reason it's wrong is the whole idea. The obvious way is to just number them. Take a dictionary. Aardvark is 1. Aardwolf is 2. Abacus is 3. Carry on for 100,000 words. Now every word has a number. Job done. Except look at what you've built. Numbers have an order, and they have distances. 3 sits between 2 and 4. 90 is a long way from 4. So you've just told the machine that aardvark and aardwolf are practically the same thing because they're right next to each other. And that cat and kitten have nothing to do with one another because one is number 12,000 and the other is number 51,000. You gave it an order, but it's alphabetical order, which means nothing at all. So here's the fix, and it's lovely. Don't give each word one number, give it a list of numbers. Say 300 of them. Because a list of numbers isn't a position on a line anymore, it's a position in a space. And in a space, things can be near each other in more than one direction at once. So now, every word is a point on a map. And here's the question. Who decides where each word goes? You already know the answer. Nobody does. It's the same trick. Guess, check, nudge. The machine is trying to guess the next word, and it shuffles all those positions around, a tiny bit at a time, into whatever arrangement makes its guesses better. And it turns out the arrangement that makes guessing easier is the one where words used in the same way end up in the same place. Nobody drew that map. Nobody wrote a list of synonyms. The map is just what falls out of trying to guess the next word a few billion times. Which means you can now measure something you never could before: how far apart two words are. Dog and puppy? Close. Dog and stapler? Miles. And that is genuinely useful today. It's why you can type receipt spelled wrong and search still finds it. You didn't match the letters. You landed near the right place on the map. It's why you can ask for something cheaper and get results about budget options when you never said the word budget. And it's why, when you're writing a prompt, the exact word you pick matters less than people think. What matters is the neighborhood you're pointing at. So if you're getting the wrong sort of answer, don't go hunting for a better synonym. Give it more context. Move the whole neighborhood. Right. We can turn words into positions, which means we can finally feed it a sentence, one word at a time. It reads the first, holds on to something, reads the second, updates, and that works. For a while. But by the time it reaches the end of a long sentence, the beginning has faded. Ask it about something you mentioned 20 words ago, and it's gone. So, memory fades. And the fix is not a better memory. The fix is to throw memory away. Here's the idea. It's the one that changed everything. Stop trying to remember as you go. Keep every word in front of you at once. Nothing gets carried forward, nothing fades. Then, for each word, look back at all the others and work out which ones actually matter to it. That's it. That's the whole thing. And for once, the name is exactly right. It's called attention, because that is literally what it does. It pays more attention to some words than to others. It came from one paper in 2017 with possibly the most confident title in the field. Attention is all you need. Let me show you. Here's a sentence. The report you asked me about on Tuesday was already sent. Now take the word sent. What does it need to know? Not much. It doesn't care about Tuesday. It doesn't care about you. It needs to know what was sent. So it looks back along the line. It weighs up every word. And almost all of that weight lands on one of them. Report. Nobody wrote a rule saying sent refers to report. It worked that out from the same trick as always. Guess, check, nudge. And now the bit that actually mattered. It looks at every word at once, instead of one after another, which means you can work on all of them at the same time. The old way was a queue. You couldn't start word 10 until you'd finished word 9. This isn't a queue, it's a room. And that is the difference between standing in line and 10,000 chips working on the same sentence at the same moment. Which is why this idea, and not any of the others, is the one that let these things get enormous. Now, one thing about how this behaves. It explains a very common frustration. Attention gets shared out. Every word divides up a fixed amount of it. So the more you put in front of it, the thinner it spreads. Which means a bigger context window is not the same as a better answer. It's just more room. And filling the room has a cost. So here's what to do about that. If you're pasting something long, put your instruction at the top. Then put it again at the bottom. Not because it forgets, because the middle is where the attention is thinnest. And if a conversation has run on and the answers are going vague, don't fight it. Start a fresh one and paste in a summary. You're not losing anything. You're concentrating the attention. Right. Look at where we are. We can turn words into places. We can read a sentence and work out what refers to what. And our machine is still useless because it is tiny and it has read almost nothing. It knows the shape of language. It doesn't know one thing about the world. It knows the shape of language and nothing else. So we fix that the only way you can. We show it everything. Not 1,000 films this time. Not 100,000 words. Everything anybody was willing to hand over. Books, articles, forums, manuals, arguments, recipes. And we give it one job. The same job it's had all along. Guess the next word. That's it. Nobody labels anything. Nobody writes the answers down. You take a piece of real text, hide the next word, and let it guess. Which sounds far too easy to produce anything useful. And this is the part that surprised everybody, including the people building it. Because think about what guessing well actually requires. The capital of France is blank. To fill that in, you have to know it. There is no clever trick. Guessing that word well and knowing that fact are the same thing. Now do that with grammar, with tone, with how an argument usually goes, with what normally happens next in a story. Guess the next word a few trillion times, and all of that has to come along for the ride. Not because anyone asked for it, because it's what guessing well requires. And the more text they showed it, the better it got. For a lot longer than anyone expected that to keep working. Now, I want to be careful here, because this bit is genuinely argued about. There is real disagreement over how much of what came out is new ability and how much is very good pattern matching. Nobody serious thinks that's settled, so I'm not going to pretend it is. But the recipe that came out of it is not argued about, and it has 3 stages. Stage 1, pre-training. All that text, guessing the next word. This is where the knowledge comes from. It takes months, and it costs a fortune. Stage 2, fine-tuning. Now you show it a much smaller set of examples of the behavior you actually want. Questions and good answers. This doesn't teach it anything new. It teaches it what it's for. Stage 3, manners. People rate its answers, and it gets nudged towards the ones they preferred. This is where helpful and polite comes from. Knowledge, then behavior, then manners. And here's the thing to hold on to, because it explains an enormous amount. None of that is a lookup. There is no table. There is no copy of the internet in there. All that text went in, and what came out the other side is a very large pile of dials. When it answers you, it isn't finding the answer. It's rebuilding something that sounds like the answer out of the shape all that text left behind. Which is exactly why retrieval exists. When it matters that something is true, don't ask it to remember. Give it the document, or let it search. Then it's reading instead of reconstructing. So, it has read almost everything. It can finish your sentences. It is genuinely useful. And it will also tell you, with complete confidence, something that is completely false. Right, this is the part you came for. 6 things your AI does that drive people mad, and for every single one of them, you already know why. 1. It makes things up and sounds completely sure about it. Remember what it was trained to do? Guess the next word. Make the plausible thing. Nothing in that process was ever pointed at true. And sounding right and being right feel identical from the inside, because it hasn't got an inside. So don't ask it to be accurate. Ask it for sources you can check. Or hand it the document so it's reading instead of remembering. 2. It can't tell you how many letters are in strawberry. We opened with this one. Here's the answer. It never saw letters. Words get chopped into chunks before it ever sees them, and it learned about the chunks. Asking it to count letters is like asking someone who reads whole words by shape to spell one backwards. So don't ask it to do letter work or character counting in its head. Give it a tool, or do that bit yourself. 3. It ignores the middle of a long prompt. Attention gets shared out, a fixed amount, divided across everything you paste in. Put more in, and the middle gets the thinnest slice of it. So put your instruction at the top, and then again at the bottom. 4. It gives you a different answer every time. At every step, it has a whole spread of likely next words, and it doesn't always take the top one. That's on purpose. Always taking the top one makes it flat and repetitive. So if you need it identical every time, say so. Ask for a fixed format. And when you want it wilder, ask for 5 versions in one go. 5. It agrees with you far too easily. Stage 3. People rated its answers, and people rate agreement highly. Being told you're right feels like a good answer. So stop asking, is this good? Ask it to argue the opposite. Ask what's wrong with it. Give it permission to disagree, out loud, in the prompt. 6. It does better when you tell it to think step by step. This one is almost silly. It works out its answer as it writes. So if it writes more before it answers,
it has done more work. So ask for the reasoning first and the answer last, not the other way round. That's 6. And every one of them came from the same place. Not one is a mystery. Not one is really a bug. They are all just what a next word guesser does when you ask it to be something else.
So that's how it works. All of it. You have the whole thing now. Which means I owe you the other side. It doesn't understand cause and effect. It has seen a billion sentences where two things happen together. That is not the same as knowing one made the other happen. And it can't tell the difference. It is unreliable over long chains of reasoning. Every step is a guess. Guesses compound. 6 steps in, the odds are not on your side. It needs an absurd amount of data. A child sees a handful of dogs and has the idea for life. This needed millions of pictures. Whatever people are doing, it isn't this, and nobody has really solved how to test these things. We have benchmarks. Benchmarks are exam papers, and you already know what happens to exam papers. Then there's the cost. Training these things uses a serious amount of energy. Running them uses more, every single time anybody asks anything. The text they learned from was written by people, mostly without being asked. That's a real argument, and it isn't finished. And they are already changing what some jobs are, not by replacing whole ones so far, by hollowing out the middle of them. If your work was mostly first drafts, that has already moved. But here's the one I'd actually worry about. These things are confidently wrong, and they are being put in places where confidently wrong hurts somebody. Medicine, benefits decisions, hiring, anywhere the person on the other end has no way to check. And you now know exactly why that's dangerous. It isn't lying to you. It has no idea it's wrong. There is nothing in it that could know. So if you take one thing from all of this, take that. Use it where being wrong is cheap and easy to check. Be very careful where it isn't. And if you want to go further, 3 steps. Go and use the playground. Drag the dials yourself. Break it on purpose. Then pick one thing from this video that annoyed you, and go one level deeper on that one thing only. Then build something small and useless. That teaches you more in an afternoon than a month of watching videos, including this one. Right, back to the beginning. At the start, I gave you the answer you find everywhere. And I told you it was useless. Deep learning is a way of getting a computer to work something out from examples, instead of being told the rules. Read it again now. Every word of that sentence has something behind it. Examples. 1,000 films with 1,000 scores. Then the whole internet. Work something out. Guess. Check how wrong you were. Nudge the dials. A few billion times. Instead of being told the rules. Nobody wrote a rule that said sent refers to report. Nobody drew the map. Nobody set a single dial. Same sentence, completely different sentence. And one last thing. There was never one breakthrough here. Every part of this video existed because the thing before it broke. One dial could only draw a line, so we bent it. We couldn't turn billions of dials by hand, so it rolled downhill. It cheated, so we hid the test. Words weren't numbers, so they became places. Memory faded, so we threw memory away. It knew nothing, so we showed it everything. 7 times something broke. 7 fixes. Which means when the next one arrives, and it will, you already know what to look for. Not what it can do. What broke.